Ever wondered why your coffee turns cold if you leave it untouched, but never the other way round? It's a question that, at first glance, might seem trivial, but it actually taps into a profound concept that governs everything around us, the laws of thermodynamics. These laws are like the rulebook for energy and its behavior, dictating how and why energy moves around in the universe. Among these, the second law holds a particularly intriguing position. It's the one that tells us why time only goes forward and not backward, why your ice cream melts in the sun, and yes, why your coffee doesn't spontaneously heat itself up. This law talks about a concept called entropy, a measure of disorder or randomness. And it's a pretty big deal in the realm of physics. So, buckle up as we dive into the intriguing world of thermodynamics. The answer to this lies in a fundamental law of nature, the second law of thermodynamics. So, what is this second law of thermodynamics all about? Well, let's start by simplifying it. Imagine you have a cup of hot coffee in a cool room. You'd expect over time for the coffee to cool down, right? That's pretty much the second law of thermodynamics in action. It's all about the flow of energy and how it naturally moves from a state of order to disorder. It's this flow that powers our world, from the burning sun to the turning of the earth. This concept of disorder is known in thermodynamics as entropy. It's a bit like that pile of laundry you've been meaning to sort out. Left to its own devices, it doesn't get any tidier. In fact, it probably gets messier. That's entropy. It's the inevitable trend towards chaos, and it's a fundamental part of our universe. However, not all energy is equal. The second law of thermodynamics states that not all energy in a system is available for work. Think of it like a team of workers. Some are super productive, others not so much. The energy in a system is the same. Some of it can be used to do work like powering a car or lighting a bulb, but some of it inevitably gets lost along the way, usually as heat. That's why your car engine gets hot when you drive, or why your laptop warms up when it's working hard. It's the lost energy, the unproductive workers of the energy world, escaping out into the universe, never to return. In essence, the second law of thermodynamics is about the natural tendency of any isolated system to degenerate into a more disordered state. It's the law that describes the cosmic trend towards chaos, the inevitable march of entropy, and the relentless river of energy that powers our universe. So, what are the key points we need to remember about the second law of thermodynamics? Firstly, this law introduces us to the concept of entropy, which is essentially the measure of disorder in a system. The second law states that the entropy of an isolated system will always increase over time. Secondly, it tells us about the directionality of energy flow. Energy, according to this law, moves from places of higher concentration to places of lower concentration, a phenomenon we see in heat flow. Thirdly, the second law also talks about the quality of energy. It dictates that when energy is transferred or transformed, more and more of it is wasted, often dissipated as heat. Finally, the universal applicability of this law is key. It governs everything from the simple physical systems, like your coffee cooling, to complex biological processes within our bodies. The second law of thermodynamics, therefore, is not just a law of physics, but a fundamental principle that governs our everyday lives.